Hello and welcome everyone. My name is Piotr Graniczka. I'm a product owner here at Hexagon, and today I'll lead you through Designer 2021.1 sheet metal tech brief. And just a remark, this presentation will be recorded and I will upload files used in that presentation for your reference, so you can watch it again later on and practice on the exact same part which will be used today. Okay, as for an agenda, I will start with what is new in 2021.1, and I will start with setting up shortcuts. And this is a really nice, handy thing, and I'll be using it a lot today. Then I will move to our ability to send part names and instances to RAID and traditional. Then I will will show a little bit of conical bends unfolding. Then I will explain how software behaves with clashing models, so those which are in clash after unfolding. I'll show you new add tab command. I will talk about enhancements to our retrieve side bend command, enhancements done to our wedge corner reliefs command. I will show circular corner reliefs, ability to send to rad code, and I will tell a little bit about backward associativity and what it is, where we are with it at the moment, as well as enhancement or toggle command, which is linked to backward associativity slightly. Then I will skim over what was added in 2021.0. I'm sure most of you are already familiar with these commands, but just for those who aren't, I will go through highlights which we have done for 2021.0. And these are enhancements to split edge command, watertight corner relief, remove bevel command, shell command, cut flange, edit split, and our ability to send to RAID traditional. Later on, I will do 3 demos. 2 of them will demonstrate our capability to create part from scratch. And the third one will show how to fix bad model, how to turn it into fully manufacturable part, how to verify if it is fine or not, and then how to send it to CAM. Okay, let's move on. I'll bring Designer Beta 2 on my screen, and I will drag and drop first assembly. So that's how it looks. So I will start with shortcuts. In this version, we can have unlimited number of icons here under right-click menu. Also, we can define different sets of shortcuts depending on selection. So if I click on a face, I may have different set of shortcuts. If I click on the edge, I may have a different set of icons. I'll be using these shortcuts today a lot because I think they improve workflow greatly and improve user experience greatly. And say if you'd like to add something to these shortcuts, you simply right-click, click on this right-click icon. Then from here, you can pick whatever you want. Let's say this one. If I hit plus, it gets added to the bottom. So from now on, I have this icon under my shortcuts. To remove it again, I can click on this remove icon to get rid of this shortcut. Obviously, you can position them however you want by moving them up and down. You can decide how many icons you'd like to have per row. So say if I want to have 5, I have 5 per row. I will get back to 10, but you can configure it however you like. One more second, I need to get rid of this. Okay, I will start with our ability to send part names and instances to our traditional product. So if I expand here, you can see that I have 4 identical parts called part A, 2 identical parts called part B, the same with part C and part D. So they are instances of the same part. So now if I set part properties on this model, and then if I go and send it to Radon Traditional, all this will end up in import helper. Stretch it a little bit. All this ended up in an import helper with the correct quantities. If I would like to, I can increase the assembly multiplier. So if I'd say would like to manufacture 5 of them or 6 of them, I'll maybe switch that on again. I can increase multiplier here. So let's say if I would like to manufacture 5 of them, if I hit apply, all these required quantities, they get multiplied. Okay, the way it works is that software looks for a part name and it finds, if it finds solids with the same part name, software assumes that this is the same part and it just throws the quantities to Radon Traditional. Okay, I'll now move to conical bends. So in 2021.1, we are able to unfold models which do have conical bends. So if you can see model like this, if I hover on top of this face, and if we read 5th row from the bottom, it says the type of this face is conic. So if we have models with conical faces, we are now able to unfold them and manufacture them. Another example looks like this. Set part properties on it. I am able to unfold it as well. There are a couple of things worth mentioning. First one is that we have new cone feature, which represent conical bands. And this type of features, they get k-factor set to 0.5 by default. There's also another thing, is that we are, at this moment, we are able to unfold models with faces, with type of faces which say conical. If, for example, your model has face which the designer intent was to be conical, but it is variables, for example, variable radius blend. In this version, we probably will not be able to unfold all of this, but that is something we are actively working on. And in the next release, the range of models will expand. We're hoping to include that change in this release, but it was slightly too risky at this stage of development to include that, so we decided to postpone it. Okay, let's move on. Now I will demonstrate problematic models. So problematic model like this, for example. So in previous version, if you tried to unfold it, it will just say it's not possible to unfold. And in this version, if I set part properties on this model and then toggle unfold view, full flanges get colored red. If I toggle unfold view, I can clearly see on the unfold where the problem is, so I can fix it. So I'll toggle it back to folded state and say I will pick this edge, go with chamfer, confirm that. We'll do the same thing here. If I now toggle unfold view, software now analyzes the model again. These two flanges are now blue, so we can see there's no problem here. But if we zoom out, we'll see now that these two are in collision. So I'll have to fix these two as well. I'll click on this face, go remove. I will include this face to the selection as well. So they're both fixed. The next thing I'm going to do is I'm going to use chamfer option, box select these two edges and just increase that chamfer. Maybe that's slightly too much, but if I bring it to the flat state, we can now see that model is ready to be manufactured. There'll be no problems with it. So this is quite a nice enhancement. We can now see exactly on the unfold where the problem is. Okay, let's move on. The next thing I would like to show you is renew at tab command. So I have maybe slightly bizarre odd model, but it will demonstrate capability of this command. So what I'll do now to start with, I will click on edge, I will go add flange, and I will drop it up to this vertex. So let's say what I would like to do, I would like to close this whole area. So I would like to extend geometry of that flange to match this geometry. So what I'll do, I will create new work plane on this flange. Then I will use project on a work plane command. If I now go to correct filter, so edges, tangent edges, I will click this line and then this line. And what it did, it actually collected all that tangent chain and drop it on my flange face. So I'll confirm this one. I'll do the same thing here. And the next thing I'll do is I will use a line command and I will join these geometries together like this. And then I'll use it from this vertex to here. Next thing I'm going to do is I'm going to use trim command. I'll trim this end and this end. Okay, again, trim. So what I ended up is a nice region, which looks like that. If I go Alt tab, it just filled it with material. So if I unfold, that's what I'll end up with. Maybe not directly related to this command, but I'll show you one nice trick. If I pick this edge and go add flange, what I can do, I can create new work plane here. I'll drop it on this flange. I will now select this face and use project on a current work plane, and my geometry has been directly copied from the other flange. So this is a nice way of translating geometries from one flange to other parallel or not necessarily parallel flange. Okay, so this is at tab command. I was using regions, and that button is here to switch on region or switch off region, but it does not necessarily mean that you need to have regions to use at tab command. So let's say if I go with a line, drop it here, turn it into arc, draw a straight line. I can select these two and go to add tab command, which I have shortcut here. If I select these two, it will work as well. So yeah, let's move on. The next thing I would like to show you is an enhancement we've done to trim side bend command. I will open a sample model to show you how it works. It is a small enhancement, but I would say very useful. Sometimes you need to trim bend a little bit. And in the past, whenever you were using trim side bend commands, software tried to find the most reasonable depth for that trim, which was related to bend radius and thickness. But sometimes it was maybe not what user would like to have. So what we've done for this release, we have introduced a slider from within trim side bend command. So user now being within this active command can adjust the depth of it. So as an example, I will snap it to this vertex. If I confirm set part properties on this model and then unfold, I have model fixed and ready to manufacture with this corner reasonably nice. Another enhancement we have done is enhancement to our wedge corner relief command. In previous releases, wedge corner relief command worked only on convex shapes, convex shells. It just did not work on models like this. So if you had like inverted scenario with a slightly concave two faces, it just did not work. So if user wanted to open this sort of corners, he had to preferably add bends first, then trim these bends, then split that edge, then adjust the position of that trim. Now with this enhancement, wedge corner relief just works in these sort of scenarios. And because these models, these shells, they come in many many shapes, many variations of our angles in between. We have also introduced a checkbox called reverse side, which changes the shape of your wedge, because in some combinations of angles, just this one is more suitable. It looks better, it fits your model nicer. But most of the cases, because at least two flanges, they have 90-degree angle between each other. This one is default shape. Okay, I'll show this later on whenever I'll be fixing bad model. So we'll get back to this a little bit later. Okay, the next thing I'd like to show you is our circular corner reliefs. But maybe before I start, there is something I would like to mention. So I will drag and drop model. And here we have checkbox called healing, which can be switched on or switched off. From generic designer user, healing option switched on might be beneficial, but in most cases, from the sheet metal perspective, it's safer to have it switched off. I'll tell you why. If I imported this model, it got in as a single solid. If I go analyze, validate, check it, and display problem zones, it will point you that there are many face-to-face inconsistencies, which is basically touching edge problem. We are healing these sort of scenarios kind of in a background whenever we are using set part properties command. So if we do set part properties command, we are introducing split here, so we do not, from now on, model is valid. But if you were to pull this model again with healing switched on, model may get imported as a group of individual faces, which then have to be joined together, and it's just a bit more work. So if it comes like this, make sure that your healing is switched off as our set part properties command we'll look into that problem further down the line. Okay, circular corner relief command. So it's here. You can also have it under the shortcuts. So if I now pick these two bands, software will not let me apply circular corner relief. It is because circular corner relief command relies on material properties. So it needs to know where the neutral fiber lies. So it then produces the correct shape. So if you want to apply circular corner relief, we need to first set part properties on the model. And from now on, circular corner relief command will work. So I need to click two bands and we see relief. What we can do with it, we can change its diameter. So let's say I will turn it from 5 to 4. Also, we can change its position by modifying value in relief offset field. If you imagine a bisection, or if you have 90 degrees here, imagine that you have half of it, 45 degrees line. By modifying this value, center of your circle will travel along this line. So if I say type in 1, it will just move a little bit to the inside. So you can tweak these things if you want. Once this command is confirmed, I can unfold this model and we have a circle on the unfold. If we now then send this model to nesting and then tool it with punching machine, that corner will be picked by a single round tool hit. So everything will get manufactured as we want. There is one point worth mentioning. If we now do anything to this model, which changes its unfold position of neutral fiber, if I set part properties again, software will warn you that this corner relief is out of date and it will highlight side faces in red color. So you have to modify it manually. And we will be working in future towards making this process more user-friendly, more automatic, but that's where we are at the moment. Okay, the next thing I would like to show you is our ability to send models RAD code. I'll open an assembly. It is loading at the moment. Then I will set part properties on this model. I'll use stainless steel. Okay, and just for the purpose of this demonstration, I will edit thickness on this model. And I will change its material to say aluminum. And I'll change it only on this model. So now what I will do, I will send it to RAD code. I'll save it first, maybe in my temp folder. And now RAD code will get triggered. Okay, I'll pick anything. Okay, now RAD code says that I do not have this material in my setup. So I would like for default stainless steel, I would go for stainless steel and choose the same thickness, apply it for all. Also, it says that aluminium, so it picked aluminium as well. I'll go for aluminium. I'll use the same thickness. I will skip strategy. So we can now see that we have right thicknesses, materials, as well as quantities imported to RAD quote. I can now close it. Okay, so we are now able to send files to RAD code. The next thing I would like to show you is backward associativity, and try to explain what it is and how it works. So let's say I have a model like this. If I now toggle the view, so I'm the moment my unfold, if I do now any changes to my unfolded model, if I go, say, remove this fillet, and if I now get back to my folded view, this change will get fitted back to my folded model. So there is a two-way connection. We can see that change appearing on my folded model. So a handy, also another handy tip, maybe not related to that backward associativity, is that let's say if I would like to remove all of these blends in one go, if I go now and pick remove face, there we have smart selection settings. If I enable that filter, and here in settings, I have same radius. If I click on this face, software scans the whole model and finds geometries with the exact same radius, so I can do stuff in one hit. And that changes got updated in my folded model as well. And this might be, these filters, they may be used in various places. So let's say if I go and, for example, want to edit bend radius, and if I go for smart selection, we'll pick the same radius, it finds all of the bends with the same radius. So this might be a nice validation tool if, for example, you have a model and you want to make sure that all bends, they have the same radiuses, or you want to remove or make all the holes with radius 9.8, turn them all into, say, 10 mil or whatever. You can do that as well by using that filter. So if I go, for example, remove face with, again, with that filter switched on, it picks all of the holes with the same radius on your model. That might be a handy way. One more thing I would like to mention is that two more things really relating to backward associativity. The first thing is that it sometimes might be more might be better to work on the unfold rather than on a folded model. For example, I would like to get back that blend here in that corner. I can go blends, and if I select it here, I may accidentally select other geometries by mistake. But if I do the same thing on the unfolded model, I do not have that risk. I can select them without the risk of selecting other geometries which I may not necessarily want to select. If I toggle unfold view, all this will get updated, as we can see. Another thing is that we have enhanced our toggle refresh command. That means that this active layer gets switched automatically whenever we are toggling between folded and unfolded state. So that saves user that extra step of manually remembering to change the active layer whenever he's on the unfold view. As it stands for today, I would say that this backward associativity works on flanges, but I would be careful with modifying bends. Be honest with you, it sometimes works, sometimes doesn't. As this release, backward associativity works on flanges. Okay, that's all I wanted to tell about 2021.1 release. I'll now quickly skim over the things which were added into 2021.0 release. We'll start with enhancements to split edge command, watertight corner relief, and remove bevel. So I'll get back to my designer and I will load sample model. So these are changes which were done in 2021.0 release. So before that, if we had show like this, and if you would like to open, say, this corner, probably what user would have to do would be applying corner relief here, then splitting this edge, then splitting this edge as well, then tidying up this corner, then very likely making, so I need to pick that edge, making sure that this radius is nice for welder to weld. So these are all the steps user would have to do to open this sort of geometry. So if I click undo, 1, 2, 3, 4, 5 operations to open it. But split edge command was enhanced, so you can select whole chain and it applies that split straight away with a single click. So that was first enhancement to split edge command, ability to cope with arc edges. The second enhancement for a split edge command was its ability to cope with bend geometry. So say if I have something like here, say I will go and pick split face command and I will open it here. I can pick the bend and go directly to split edge command, which is here. If I click it, I can very quickly get to where I want. So it is now possible to use split edge command and turn bends into splits if we need to. Okay, I'll now show watertight corner relief command. So if I click on maybe I'll switch those messages. Okay, if I click on bend, I have watertight corner relief in my shortcuts. I'll click on the another bend and watertight corner relief got applied. We need to adjust the gap size. We can do it manually, or we can use a ruler and go for distance between 2 points and just measure it. And software loads that measurement directly into this field, so you're sure that it has the right size. I'll do it again, 0.1. So we now have watertight corner reliefs applied. One last thing, if we look on this model from this side, we can observe that this is just a straight extrude cut. Not very good from sheet metal perspective, as it is likely that user will not want this bevel here. So what we can do with it, we can use our trim side bend command just to trim it slightly, and then we can then click on this edge and go for remove bevel command. So it squares it off. If I now set part properties on this model, I'll go for automatic selection. We can now see that it is it's ready for manufacturing. You can send it and cut it and fold it. Okay, that was the first thing. The Next thing I would like to talk about is shell command, cut flange command, and edit split command. So if I get back to designer, I will open new file and say I'll draw something fairly simple, say 300, without worrying too much about dimensions. I just need to make sure that this line is vertical. Okay, I'll switch regions. I'll go for extrude. So at the moment, I have a field solid. What I can do with it, I can turn it into shell and then turn it into sheet metal part. So how the shell command works is that I'm selecting solid, then I'm choosing faces to remove. So my shell would look like that. I may wish to have more faces removed to have enclosure like this. That's what I'll do. Obviously, you can change the thickness. You can change the thickness direction. So either it will be outside your solid or inside your solid. I'll go with thickness 3 and confirm it. So what I'll do now, I'll show you cut flange command. Maybe I'll create a work plane on this flange. And what I'll do, I'll select this face and I will go for offset command. So if I click it, I can now modify the depth. I may offset all of the edges which surrounds that face. Say I will do -30, for example. Once I have it, I can select it and then I can click cut flange command. So it cuts through the thickness of that sheet. So if it's 0, 0 here, it knows it automatically reads the thickness. I can also drag this slider to cut through more faces if I wish. So that's basically how cut flange command works. Is a way to cut your sheet metal parts. Okay, the next thing I'm going to do is I'm going to maybe hide these wireframes, and I will include some corner reliefs in these corners, here, and here, and say I would like to turn it into sheet metal part. So what I will do, I will select this face and I will go for add bend command. And again, it finds edges around that face which are suitable for applying bends. I can still edit that selection and manually add more if I want to. I'll add them to these 4 edges. Then I will use split edge command, box select everything, and it opens that model. If I set part properties on it and then toggle unfold view, that's what I ended up with. So I'll fold it back up, and let's say I don't like this. I would like to have bends here and splits here. What I can do, I can utilize edit split command. I'll pick first edge, we'll pick second edge, and I can either do sharp corner, I cannot bend with a defined radius, or I can modify existing split. So I can change if it's left hand, right hand, I can change the gap. What I will do, I will apply bend here, as well as I will apply bend here, and then I will utilize what I said earlier. I will just turn this bend into split, and I will turn this one as well. So if I now toggle unfold view, my unfold looks like this. So this is a handy tool of swapping between bends and splits. Okay, once I'm happy with that model, I may wish to tidy up this geometry slightly. So we can use remove face to get rid of this unnecessary reliefs. If I want to make it nicer, I can apply blends here with the correct radius so it is nice for welder to put the weld around it. Okay, so this was showing shell command, cut flange command, and edit split command. Obviously, we can now send this model to CAM, and that would send this single part to Raiden part editor, or we can send it to nesting. So I'm sure you're all familiar with these commands. Now I will move to the second part of this tech brief. I'll do 3 demos. So 2 demos will refer to create part process, and the third one will demonstrate how to fix bad model. So, okay, let's get back to designer. Maybe I'll start with creating part commands, and then I will fix bad model. Okay, so I will now use a polygon command. I hit polygon, hit on the center. I have a hexagon on my screen. I can modify the quantity of sides to get different shapes. I can choose various settings, if it's inscribed or circumscribed, define the radius, etc. I will just apply this shape. What I'll do now, I will go for create part command. And if my profile is closed, it will create sheet metal part without any bends. The next thing I'll do, I will create a circle on this model, and I can define it by diameter. So say 220, quite a big hole, and I will use this circle to cut through this flange. The next thing I'll do, I'll just hide this wireframe. I will go pick this edge, and I'll go add flange command. Say the length of it will be 100. I'll do the same thing here. The next thing I will do, I will create my work plane anywhere on this flange, which means that my intent is to draw on this flange. Then I'll pick this edge, we'll go offset, and I will create some construction geometry. Say, I'll go with 30. Then I will pick it from the other side, say 30 as well. Then I'll pick this edge and drop it, say 44 as an example. Right click to confirm. Next thing, I'll drop on this intersection some holes, let's say 12, maybe bigger, 16. I'll do the same thing here. I will use now these two to cut flange. Then I'll add some chamfers here and here. So it is looking like this. The next thing I'm going to do is I'm going to use quick search, because I know that command exists. I'm not entirely sure where, but I remember command's name. I'll start typing in the axis. Draw axis, sorry, yeah. Click it. If I pick this face, software will draw axis of that cylinder. I'll confirm it. Then I will go solids, rotate feature. I will select all of these faces. Then as a center of rotation, I will pick point along that axis and then this axis, and I'll create a copy along that axis. So I can choose how many copies do I want. If I want to have 2, I have first copy and second copy. If I type in 5, I have 5 copies, and I have equal spacing, full rotation. I can change these settings to, say, type in as many as I want. So I can go, say, 5. And if I want to tweak it later on, I can always use delete flange command. say delete this one, delete this one, delete this one, and delete this one. So it is a quick, simple demo, but we are now able to rotate flanges around axes. Okay, the next demo, if it comes to create part, I will draw, this time I'll draw open profile, say 375, and I'll go 50 in this direction. I'll use this open profile again for a creation of a new part. So there are various settings in create part command. You can change the thickness, change the thickness position, radiuses, etc., direction of extrusions, and so on. What I'll do now, I will create new work plane on this flange, confirm it. And this time I'll select this edge and I'll select this edge, and I will use project on a work plane command. Once I click it, these two edges, they got projected on this flange, similar to what I've done for a tab command. I will then pick this edge and offset it slightly to the inside, say 36. I will do exactly same thing from the other side. I will do it from the top, let's say 24, and from here I'll do 18. So again, I have some construction lines. What I'll do now, I'll go for a circle and I'll drop here something, say 10 mil, and I will use it to cut flange. I'll cut through both flanges simultaneously. Now, what I'm going to do, I'm going to use create pattern command, and I will select this face. So what this command does, it allows you to create pattern of features. So you can either define your pattern by spacing. So if I type in 100 as an example, there 100 mil is the distance between instances, or I can define it by total length, and then it takes that total length into account. So I'll change the vertical number of the 2, horizontal into 8. What I can also do, I can use this slider and just snap it to my existing reference geometry, so I do not have to do any math. I can use existing lines, vertices, and so on. If I include this one into the selection, it will get propagated on both flanges. If I were to forget including this one, what I could do, I could create a work plan on this face and just project this face onto this one and use new geometry to cut the other flange with cut flange command, if that makes sense. Okay, the next thing I'm going to do, I'm going to use rectangle command. I will find the center of this line, so I can modify the width and the height of this rectangle. What I'll do next, I'll switch on regions, and I'll pick this region and go with extrude command with a subtract option to cut it. So we can now unfold this model. That's how it looks. One last thing I would like to do on this model, I would like to cut some slots out of it. I'll drop new work plane here. Then I will go to wireframe, rectangle, slot, and I will switch equidistant point as a filter. So if I now find the center of this edge with the center of this edge, my actual selection point is the middle distance between these 2 points. So I'm now sure that my newly created slot is in the middle of this flange. I can adjust the size of this slot currently we are only able to define it by the distance between these two arcs. Okay, I will drop it. Now what I'll do, I will use it for cutting flange. So I have this cut. What I'll do now, maybe I'll hide this wireframe. I'll switch to normal view. And again, I will use create pattern command. I will select these faces. So this time horizontally, I want 1. I will go for total length and I'll increase the quantity of it. So I can define the length, or I can use ruler to measure distance from this edge if I want to. I'll confirm this one. Sorry. I'll do that again. And this time I will reverse direction. Sorry. So now we are sure that this pattern is symmetrical from the center. So that's how it could be achieved. And yeah, model is ready for manufacturing. Okay. The last thing I would like to show you is our ability to turn part models into fully manufacturable models. So I'll open another file. So this file gets in as a one big solid, and it's built from various sheet metal parts as well as well-done nuts. And this model is very, very similar to what I have received from one of our real customers. It's very, very similar to it. And the original intent of the guy who had to deal with this model was to redraw it from scratch in Inventor. So yeah, he said it would take him an awful lot of time to redraw it in Inventor, and even more to make sure that they are identical, that there are no mistakes, that all these holes, nuts, etc., that all of it is in the right position. And that would take him ages, he said, but this can be easily achievable in Designer. So I'll show you how. So what I'll do, I will start with remove face command. And here we have a checkbox called extract. I'll go for it. And what I'll do now, I will select all the external faces of this model. So just like that. So what this command actually did, it just took a skin out of the external boundaries of that model. And also, if I have this knitted sheet bodies checkbox checked, if it's switched on, it will merge all these sheets into one joint entity. If I switch off translate, it will just leave it the way it was. So in the place we are interested in. So if I hide this solid now, I have this skin directly on the top of it. So my next step will be making sure what is the thickness of it. It says 2 mil. Okay. I will get back to my sheet and I will go and use offset command. I will pick it, and with this thicken setting, software will create a thick body. I just need to make sure that I have extruded it into right direction, which is inside, because I was selecting model from the outside. So that's what I have. At the moment, I'll bring this one up. Maybe I'll move this solid here and get rid of this layer. So my next step would be using simple Boolean operation. I will select my original model and newly created shell. And this way I can separate these models. So what I end up with, if I check retain tool bodies, it will just not delete that tool. It will create, it will just leave it tool the way it was. So what I have at the moment, I have loads of solids. So I will now isolate whatever I'm interested in. I'll just simply hide my sheet metal parts, and all the things which are left are nuts. So what I can do with them, I can move them to some other layer. I will just delete them for the purpose of this demonstration. So I have now these two solids. The first thing I would do is I will, as you can see, these are still made out of one solid. I will pick this edge and I will go for extrude, and with an option to subtract, I'll just cut them into two individual solids. So this one looks fine for now. For this one, I will add some bends. So if I go now and pick add bend command, which is this one, I'll pick this edge as well as this edge. So it is looking fine for now. We'll get back to this later. And now I'll get back to my main shell. So what I'll do to start with, I will apply wedge corner relief around this model. So I'll start here. At the moment, it requires quite a significant number of clicks to apply these wedge corner reliefs. But we are actively thinking on how to improve that process so it's easier for user to cope with it. So we have some ideas. Hopefully, in the next release, it will be much easier to deal with models like this. So that's what I'll do. Go around it, and last corner is here. So my next step would be applying bends to that model. What I can do, I can click on a face and again go to add bend command, and software automatically scans this face and applies bends to all relevant edges. I can modify it manually if I want to. I will do the same thing from this side. So I have all my bends applied to my shell. The next thing is going for split edge command. I'll box select everything, and software automatically scans your shell and applies splits where he thinks it's suitable. So my next step will be opening this last phase. I have the wrong filter switched on. I was still on a equidistant point. I will go for enhanced pick. I'll pick this one and this one to open this phase. So that is how it looks. Do it here and here, here and here, as well as here. I'll probably go somewhere there. And if we can see here, if I go diagonally, I would go through this hole. So maybe what I will do for this one, I'll do similar thing like I shown you earlier today. I will open it like that and then turn this bend into split. And if I want, I can tidy up this corner with remove and heal command. If we want, we can apply blend here. So that's what you can do. Okay, so you may think that, okay, model is open. Let's have a look if it works. Let's try to unfold it. Okay, software warns you that it got unfolded, but with problems. So we can now see where the problem is. It's here. So the resolution, the simplest resolution would be just to turn this band into split and manufacture them as two separate parts. Obviously, you can tidy up that corner if you wish, but I'm not going to do that for this demonstration. I'll show the remaining bodies, and now I'll set part properties again on everything in one go. Okay, so now we have 4 independent sheet metal parts, and you may think that, okay, I can now go and send it to nesting, to laser cut it. But if you were to do that, guys who are going to assemble it together and weld it together, they will not be particularly happy because it will not be easily achievable. And I'll tell you why. We can now use solid interference command to check if the model, the assembly you worked on is actually valid or not. So that's what I'm going to do. I will box select whole model, and it will tell me where the problems are, and software will color them red and green. So red, we have intersections. Green, we have contacts. So if I go for intersections, you can see where they are. Because of the way we approach this model, because of the certain order of operations, we ended up with models in clashes. What we can do with it, we can measure directly on that model how big that clash is. We can see 3 mil. That's because our inner band radius was 3 mil. So what I'm going to do now, I will hide this model, and then I will go for stretch flange command. I will pick these 3 edges and shift them to the inside by, let's say, 4 mil. And on the other side, I will go for chamfer command and say, maybe not 24, I will type in 4. So that should work. What I'll do now, I'll bring this one to visibility. I will go solid interference again, and I will select not whole model, but only these 2 to check if there are any problems in between these 2. So now you can see there are no intersections on this side. There are still some on the other side. Again, I will measure it. As far as I remember, it was 3.5, I think. 1 second. This one, confirm, and measure. I'll measure distance between this point and this point. And it says 3.4, so 4 mil should do as well. I will hide this one. What I'll do here, I will go for trim side band. I'll just stretch it a bit further to the inside for now. I will select this face, and this time I will use standard move command. I will pick this direction, and I will use it to move this face 4 mil along this direction. Next thing I'm going to do, as you can see, we have bevel because we had a straight Boolean operation. I will pick this edge and we'll select remove bevel. I'll do the same thing here. Then I will select this face, go with, say, move command, and move it to the outside. And on the bottom, again, I will do 2 chamfers. And now if I bring everything back on screen, I can verify it again. So this time, hopefully, there will be no intersection. So as you can see, intersection-wise, it's safe to go. If I now display contacts, we can still see that this U-shaped bar, it might be tricky to slide it in between these 2 flanges. I will now hide the outer one, and I will use stretch flange command. Again, stretch flange on this edge. Maybe I'll pick this one on the other end as well, and I will shift them up by 0.5, and then I may use move flange command from the top and drop it by 0.5 mil as well. Then on this end, I may wish to do a similar thing and stretch these two to the inside again by 1 mil, confirm it. And this time, if I analyze it, you can see that there are no big issues with this model anymore. We have some contacts here, but it should be safe to now send it to nesting and laser cutting, and laser cut it and just manufacture it and weld it all together. Don't see any problems with it. Okay, so getting back to my PowerPoint presentation, last thing I would like encourage you to do is to go our eSupport page. There are some videos that I have done for 2020.1 version, which now might be slightly out of date, maybe, because these commands were improved since then rapidly, but it's really worth watching them at least once, because they describe all the other commands, like, let's say, edit flange angle. It explains what is the difference between virtual axis and tangent to bend, bend radius modification, and so on. If you have questions, it's worth asking them there as well. They will get answered. Okay, I think that's all from me. I now wonder if there are any questions. I will have a quick look to a Q&A. Okay, I've seen some comments on chat as well. There are quite a few comments. Give me a second, I will read them through. The circular corner reef is great and auto updates will be excellent. This is something we would like to get eventually at some stage. It is not trivial, so we'll have to do tiny steps in that direction. But yeah, that's where we would like to be. Backward from unfold is excellent. Yes, thank you. Yeah, this is nice thing. How flexible modification in created design is. This is a very open question. I would have to see the exact model and the exact problem. You have to answer this question. It is flexible, but you need to remember that this is direct modeler. It's not parametric like, say, Inventor, CATIA, or SolidWorks. So the approach is slightly different to the way you're dealing with your 3D geometry. So it requires different, I don't know, mindset. I don't know how to explain that. If you have particular problem with your model, just drop it on a eSupport forum, and at some stage, whenever I have a minute, I'll look into it. There are obviously some limitations, but this is still work in progress product, so we'll slowly moving forward. And yeah, eSupport is the way to go. Assembly from drag and drop part. I'm not entirely sure how to answer this question. That's what I have done here. That was a single part. And now here, if you look at the screen, now here I have 4 independent solids. So what I can do, I can rename them, say, to give them something more meaningful if I want to. Say 001, save it. I can apply any names I want to particular solids and so on. Rename this one as a number 2, for example, and then I can send it for nesting, and they will get cut as individual independent parts if you wish. Not sure entirely how to answer that. That's a good question. Remove bevel is nice, but how can you check if there are bevels? Is there a check? This is a good question. I believe it is a way. I will have to check that. I'm sure there will be a command which is not fully sheet metal command. It's more used for, I think, other products like, say, injection molding products. I'll have to check that, but in theory, you could check on the unfold what is the angle between faces, and you should be able to check that. But how to do that exactly? Again, drop this question on eSupport, and I will get back to you, because I don't want to waste your time now browsing through various commands in a designer. Okay, how to remove sketch lines without removing labels? Or wireframe in layers. How to remove sketch lines without removing labels? Well, if you are in your wireframe, just do not delete all. Just do not delete labels, I would say. If you have line, just delete line. Do not delete labels. There is a bug, apparently. Well spotted. I've never spotted it before. I delete this one. I just have to hit no. Okay, that's something we'll need to check. Thanks for spotting this. I'll just write that down. So for now, just hit no. Okay, that's all I can see in the chat. Yeah, we can set, there's another one on Q&A. We can send the parts to Raiden or Radquote is something about the connection with Radband product and Radband patch module. To be honest, I'm not personally responsible for Radband, so I would drop this again on eSupport, and our Radband specialist would answer that. As far as I'm aware, this is something we are actively thinking of. Yeah, just again, cannot answer this one. Okay, I am getting a page not found on the eSupport path to the designer 2020.1 videos. Okay, I have no idea why that is. I will write that down. I'll get back to you. Maybe there is some sort of permissions required, or I will double check that. Okay. Check solid, check sheet metal is better than check body. Sheet metal is one solid with common thickness. To be honest, I don't understand exactly what this means, but I'll get back to you on this one. Okay, that's all. I do not see any other questions. I've seen something appearing in Polish language, but it then quickly disappeared, so I did not have a chance to read it fully. Anyway, thank you everyone for attending this presentation. And if you have any questions, any other questions, or some comments, please drop them on the support. It's a really good place to learn about the software and to ask questions. And again, this presentation has been recorded, so I'll upload this video so you can try it on your end. And again, thank you very much, and hopefully you will have a good time playing with Designer. Thank you. Bye.